Thank you so much for our speakers. Thank you, Vinay, Ku, Wurzel, and Sid. We are here live with our speakers. We already got a lot of questions from the audience. Please continue and send those questions. I will pass those questions to the speaker as much as time will allow. Let's start with you, Vinay, with the first question. So there is a question from the audience on the quality metrics that you're measuring in your testing. So does your test infra evaluate the actual audio video quality in the test calls?
Yes. So actually, we do have tools that actually measure the audio and video quality. That's part of the holistic set of quality metrics that we try to capture. These are actually tools that are being developed by actually a separate team. So we have a dedicated team that focuses on media quality assessment. And the plan we have is to actually plug those tools into this new infrastructure that we're building. Yeah, so in short, yes, we do measure audio video quality.
So from the questions, I saw lots of excitement about all of your work. There was this repeated question to each one of the speakers about offering your work as an open source or as a service. So we can start with you, Vinay, and then we can just go over and ask all other speakers.
Yeah, sure. I mean, we would like to open it out. Of course, it's a team internal decision we need to take, but it's nothing. There's not too much rocket science in this here that we've done. But yeah, we will definitely. We are in the very early stages right now of building this environment. It's roughly, like I mentioned, it's about 3 to 4 weeks that we're actually using it. So yeah, we will look at opening it up, at least certain parts of it, at least. At least that's our opinion, yeah.
Dr. Ku, with your quality assessment.
We also plan to have the open source available to the public. Yeah, that's the plan.
Okay, this is really great to hear. Watson?
Yeah, with respect to collagen, a lot of what we've ended up having to work on internally is dealing with systems where Facebook or Meta has their own version of things. We don't typically use AWS or Redis. We have our own version of client cloud services, things like that. So a lot of what the work we've done wouldn't be applicable outside of Meta's internal infrastructure. But I think we're happy to talk about how we went about it and help support other companies in developing the same techniques. With respect to Newton, there are some pieces of it that might be applicable that we could contribute back into WebRTC unit testing frameworks and things like that.
And Sid, you mentioned your contribution to Opus. I think many people are excited to hear more about that.
Yeah, absolutely. So Jean-Marc Villin and a number of folks who've worked on Opus work in my team actually at AWS. And yes, we definitely are upgrading Opus with additional optional machine learning capabilities and working with the IETF and other standards bodies to ensure that Opus is broadly, democratized this machine learning capability. And we also make a number of our machine learning capabilities just, available generically with our SDK and are available in the SDK in the open source package that we delivered in. So yes, we definitely embrace open source compatibility due to making sure our customers have an interoperable and compatible experience.
Okay, thank you. So Dr. Ku, the next few questions are for you. So one question from the audience: each person would give a different opinion score due to subjective difference. How do we account for this subjective opinion variation when we use MOS average to characterize a scene?
Yeah, I think that's related to the data collection process. So we have multiple viewers that give their opinion scores. And usually we need to say, take out the outliers and find the mean. But if the variance is still very large, that means this particular content may not be easy. So I think it will say it's more controversial content. So we should handle them separately. So I think that's when we do the training, basically we only have the most. But if they have the variance, we have to count differently. So that's the way we handle the data.
Thanks. So Dr. Ku, as the key contributor for the VMAF metric, can you talk a bit and compare the quality assessment that you described to VMAF?
Yeah, VMAF is a full reference method. So you have the original or high quality one, and you have a compressed one. So that's one difference. And then the second one, the VMAF, basically you have several quality metrics, and all of them based on some kind of mathematical analytical model. So you can compute those quality metrics prediction easily. And then we have the machine learning. So it's more like an ensemble learner to put multiple predictions and some feature together. So that's the last stage. So the machine learning sort of quite lightweight in that sense. But now for this green BIQA or BDQA, it's no reference. So basically you have to get the features from the content and then do the machine learning and so on. So traditionally people use deep learning, and then the model size is huge and complexity is very, very large. It's hard to put in the mobile device. So we somehow make the whole process much simpler. So simplify the machine learning and then to get a very fast prediction result.
Thanks. So in this slide where you showed the MOS score and the predicted score, it seemed like people, they are giving some artistic beauty bias. So how is that being taken into account? And does it mean that we need to add some additional features?
Yeah, I think that's related to the labels. So that's the machine learning. We have that human label. So whatever human consider good, it will show in the label. And we have a large set of so-called representations, so-called candidate features. And then based on the label, we can select more relevant one, more relevant to the human label. And then we can do the machine learning for that. So it's automatically considered in the machine learning pipeline.
Is this a codec agnostic, the quality metric?
In terms of the data set, I think it's still, we still need some kind of training. Okay, we still need to look at the different content and tailor to different content. And in terms of codec, I think so far I feel it's really not much depend on codec, because we are really using the decoded video as the way to measure the quality metric. So I think the correlation is weak.
Okay, thank you. Wurzel, I'm switching to you. There is a question on how related Newton to the fake clock in LibWebRTC unit tests and the end-to-end testing framework in LibWebRTC.
Yeah, so the LibWebRTC fake clock forms the foundation of what Newton does. If it provides that ability to give a fake time sequence for all of the components of LibWebRTC. And then the essential part for us is making sure that everything else that we add to that in terms of as we wire the two instances of the connection together, making sure everything else, the network conditioners and everything else is also operating on that same clock and using that same infrastructure. And then once you've done that, then the rest of Newton largely is a kind of a scatter gather or a map reduce kind of a function. Run a lot of simulations in parallel, bring them back, and again, aggregate to find metrics movement and identify outliers and be able to reproduce them. So as long as you're strict about making use of those components, you'll end up with something that is usable in those ways.
Thank you. So you talked about running hundreds and thousands of tests, but how do you collect realistic test configs to make it really relevant?
Yeah, that's a great question, and there's still ongoing work there. Let's look at both network configurations and product configurations. So for network configurations, in some cases, you want to design a specific network test. Testing something with a square wave or an impulse function can let you get easily interpretable data about how your algorithms are responding to a step function change, even though in reality, networks don't really generally have step function changes like that. at the same time, we've gone so far as to have contractors out there with sampling software on phones and sampling the actual packet loss and delay on certain representative networks, and then finding ways to plumb those into our test infrastructure. So I think there's a wide range of how you can get representative network configurations. As far as product configurations, that's also a challenge because we have so many users. We don't have one single product configuration. Even if you look at Messenger on iOS, for example, different users based on their phone generation, the codecs available, whether they've updated their app or not, there could be thousands of different combinations of configurations out there. And so we have to try to identify the combinations that are most common among our users, and then also consider situations where we don't want to make the experience better for the most common users, but at the expense of some small slice. So there's always that challenge of slicing to make sure that you look at the impact on particular groups, countries, bit rates, types of devices, and don't only look at the aggregates.
Thanks. Another question for you, Wurzel. Have you considered Bayesian optimization to guide simulation?
Yeah, another great question. I would say that some of our teams that use collagen or Newton could use it as a component of that, like the same way that we did the source code bisect, and we were able to treat collagen simulations as a component in that. I think if you had a Bayesian simulation you wanted to do to improve whatever parameters you were looking at, whether it was media parameters or codec tuning or network tuning, then simulations, either Newton or collagen, could plug into that as a way to be that hard to compute function. Again, the thing that we found is you really have to look at what is your use case. For us, there is no one optimal answer to what are the best network conditions, because we have people that are on workplace and trying to get a really high quality video stream over Wi-Fi or wired connections. And then we also have products that are deployed where people are using low-end Android in a very low bandwidth environment. So we do need to make sure to, again, we may have to look at completely different efforts to optimize one of those experiences versus trying to optimize the other of those experiences. You can't come up with one set of parameters that suits all of those needs.
Thank you. Sid, I'm going to switch to you. So the first question for you, for the ML models for packet loss, how to select the training datasets for model training to avoid any potential bias?
That's a great question. We actually do train for different sampling rates, like, so for example, 48 kilohertz we do create a model for that. And then if you have 8 kilohertz audio for PSTN style sessions, we also create models for that. And we also have different sparseness and density style to our models for different computational environments. So if we're working on Android devices that are really low powered, we have basically a model that's more optimized for those kind of underpowered environments. Of course, if you have a extremely capable laptop, we'll have a much more denser model that provides a little bit better quality. So we allow the developer to make trade-offs based upon a model complexity and as well on the sampling rate for the environment that they're working in. We also apply a resampler for various different scenarios. The resampling code is also open source. It's actually part of libOverTC. And there's a standard resampling algorithm that actually Jean-Marc, I think, built the first one of that. And we use that to basically resample to the right sample rates that we need for our machine learning model.
I think it leads me also to the following question about the complexity that this is adding to Opus, and really interested whether it will work well on more like low-end devices.
Great question. So in terms of complexity, coding complexity, so on the decode side, we only basically execute the algorithm when there's loss. So we can see, obviously through packet sequencing and the jitter buffer that there's loss, and that's when we actually start applying the model. So the actual decoding complexity is really limited to loss segments. And, it also depends upon the sparseness of the model that is applied for the computational environment. So unfortunately, it's not a very straightforward answer on the decode side. On the encode side, Similarly, we only usually apply it when we see actual audio. So it's not running all the time. It's only running when you actually are encoding some sort of content in the audio stream. Of course, if you're muted and things of that nature, it will not be encoding those extra frames. So we do have different models. And in fact, that is one of the big questions for standardization of Opus. Like, how do we handle different models and different complexities based upon the computational device that's running it? Ultimately, it's up to the developer actually to whether they want to use this machine learning capability or not, because as I noted in my talk, it's backward compatible. So you could, for example, not encode using the ML psychoacoustic and model that's put into play, and the neural model that we're using, and simply choose to use traditional Opus for your encode side and apply it for the decode side. So there's lots of options in terms of how the developer uses the model. And more importantly, it's not something that's we expect to be running all the time. And as a result of that, we expect the impact to the actual endpoints to be minimal, such as battery life. Actually, model size is really the big concern for the Opus team, because we don't want to create big models that increase download size and make libRGC even bigger. It's already big enough. We don't need to make it bigger for various mobile devices. So that's one of the focus points for the team.
Sid, another question for you regarding the speaker transcription demo. The question is, if we work with overlapped speech?
That's a great question as well. So in terms of overlap speech, we actually have speaker source separation mechanisms within our machine learning libraries and algorithms. And so we are able to do very interesting things like separate in an overlap or barge scenario multiple human voices. And of course, we also have a noise suppression algorithm that can basically get rid of background noise altogether as well. So yes, right now the default is we're just simply identifying a single speaker when there are multiple talkers. That's the default API that we provide. But in the fullness of time, we plan on combining our speaker source separation mechanisms that we have to basically identify multiple talkers in a single mixed audio stream that we're getting from, for example, a physical room. So that's how we basically plan on handling that barge-in scenario and that barge-in use case.
Thank you. Vinay, I would like to finish with another last question for you.
Sure.
What kind of limitations have you run into when scaling up, and can you share ideas you're exploring to overcome that?
Yeah, sure. So that's actually very good question, because as we scale up to really large numbers, we're hitting many limits, and these are typically limits that we see on AWS or Kubernetes. So there's only so many machines you can spin up, you can get. And so we need to look at how we actually optimize within the cluster. So we're exploring different kinds of ideas. One is trying to figure out how can we run multiple thin clients or clients that we run in this whole scale scenario. How many of those can we run within a certain container, and how many of those containers then you can then put within a pod? So how can we max that out? That's something we're exploring. And then obviously we're looking at an on-prem cluster version of plugging an on-prem cluster as well into the mix. So it gives us some sort of flexibility there in using our own resources. So those are kind of the options we're currently exploring, because I would say we're hitting some physical limits, if you will, as we try to scale. So yeah.
So I would like to thank again all our speakers. Thank you for coming today. Thank you for sharing from your experience. And next, we will have the session on RTC for Metaverse. Thank you again.